Grace theorem. Grace theorem, what it actually says is that it gives the relationship between a line integral and a double integral. So let's take a look at an example under Grace integral. You can get the whole picture. How do we evaluate this kind of integral using Grace theorem? How do we evaluate this line integral using Grace theorem? So the question says evaluate this where C is the triangular curve consisting of the line segments from 0, 0 to this, 1, 0 to this, and from 0, 1 to 0, 0. So let's take a look. So we are going to evaluate it using this formula. You can observe that from this, when we compare, P is simply s raised to the power 4 and Q is simply sy. So we have our line integral, which is s raised to the power 4 ds plus sy dy. So P is this, so we have P to be equals s raised to the power 4 and Q to be equals sy. So using this formula, we differentiate Q with respect to s and differentiate P with respect to y also. So when we differentiate P with respect to y, we obtain 0, and differentiating Q with respect to x, we have y. So we can now plug in into our double integral, which is partial Q, partial s minus partial P, partial y. So y minus 0 is simply y. Using this times dA. So the next thing to do is to find our limits of integrations. So from the question it says where C is the triangular curve consisting of line segments. So we are going to find an equation of a line. So we have an xy plane, xy axis, this is x, this is y. The first point is from 0, 0 to 1, 0. Let's write 1 here. This is 1 here. So this is origin 0, 0. That's the first point. The second point is 1, 0. So our x is 1, y is 0. So we have another point here which is 1, 0. Another point is 1, 0, which we have done also here, and 0, 1. So when x is 0 and y is 1, so this is simply 0, 1. And 0, 1, the same thing, 0, 0, which is the origin. So we observe that this is simply a triangular curve as described from the question, where C is a triangular curve consisting of these line segments. So we find our equation of a line here. Taking this guy, these two guys, so we have 0, 1 and 1, 0. So we are going to use the equation of a line. So we have this to be s2 y2. So we are using this formula y2 minus y1 over s2 minus s1, which is y minus y1 over s minus s1. So we plug in all these values, so we have y2 to be 0 minus 1 over 1 minus 0 equals y minus 1 over x minus 0. So in those days we have minus 1 equals y minus 1 over x. Cross multiplication, we have y minus 1 equals minus x, which is the same thing as y equals to 1 minus x. So our equation of the line here is y, our curve is y equals to 1 minus x. So the next thing, let's consider these two guys. When we do it here, we have 0, 0 and 1, 0. So this is s1, this is y1, this is x2, and this is y2. So when you do the same thing, that will be 0 minus 0 over 1 minus 0 equals y minus 0 over x minus 0. So which is simply, this will be 0 and this is y over x. So y is simply 0, which implies we also obtain y to be equal to 0. That is, y lies between 0 and 1 minus x. From our curve, our triangular curve, x is simply from 0 to 1. So our x lies between 0 and 1. Let's start from the origin and ends at 1. So we can now evaluate our double integral since we have obtained a boundary for it. So we have this to be y. So the first boundary we have, let's 0 to 1 and 0 to 1 minus x. The a is simply dy ds. So now we can now integrate. We have 0 to 1. Integrate with respect to y. We have y squared over 2 evaluated from 0 to 1 minus x dx. So now we can now plug in. We have 0 to 1 minus x all squared over 2. Plug in 0, that will just vanish. So we have evaluating from 0 to 1 minus x ds. Oops, sorry. We just have this. So let's expand this guy. We can take 2 out. We have half outside. We have 0 to 1. When we expand this guy, we're gonna have 1 minus 2x plus s squared ds. We can now evaluate. We can now integrate respect to x. So when we do that, we have x minus 2s squared over 2 plus s raised to power 3 over 3, 0 to 1. This is simply, so we have half into x minus s squared plus s raised to power 3 over 3, 0 to 1. So when we plug in these values, we have 1 minus 1 plus 1 over 3. Plug in 0, all this will just vanish. It goes away. So we have this. So we have half into 1 over 3, which is simply 1 over 6. This is the final answer. So we obtain 1 over 6, which is, so when we evaluate our line integral and using this Green's theorem, we obtained 1 over 6. Thanks for watching.